Well, Neal, well, first let me say hello to the Breakthrough Alliance community and HITLAB, and really excited to talk to Neal, who I got to hear his presentation in November and absolutely loved what he was doing. And I always like to start this off, Neal. We're going to get into your company in a minute, but I just want people to understand what your journey is. If you can tell the audience who don't know you about your career journey to being founder and CEO at Solid.
Well, sure. And thank you very much for having me on. Now, I'm not a healthcare professional. I'm not a physician. I've come to this out of left field. I'm an engineer. I've done a lot in visual computing in my life and had a hand in founding and running a couple of successful companies in the 3D business, in other areas of video and audio, professional as well as consumer before that. So I was working in the 3D area. I managed to get introduced to a fellow who became my co-founder in Solid, whose name is Rich Muller. He's an emeritus now, professor of physics at UC Berkeley. Brilliant person in optics, which is an area that I also did very little work in before. Visual computing doesn't mean you understand really how to make the lenses. So we thought we had a superior way to do light field optics. And we made the optics that we wanted to make. And then we came to see gradually as we worked with this that we could achieve some really, really special things for visual health. And I think for all health, for just so many issues. And we'll talk about that, I guess. But you know, towards the latter part of a long career working in computing, I'm able to apply that computing to the brain and to the visual system, and that's really a thrill.
Fantastic. All right, let's talk about your company now. So considering the groundbreaking achievements in correcting molecular degeneration and the promising results in increasing reading speed, can you share more about the specific ways in which Solid's prototype interacts with the brain to achieve these outcomes?
We made an amazing discovery. It's something that's been right in front of our eyes as a species from the beginning, and no one ever knew this. So we realized that if we put the right optics in front of the eye, basically almost replace the lens that you have in your pupil with a planoptic or fly's eye lens, a compound lens. We don't take out your lens. There's no surgery, but we found a way to pass light through the pupil without engaging in the focusing mechanism of the pupil. And when we do that from multiple lenses, compound lenses, the brain is able to put together a single full field stereo image in the same way that it does from two eyes with normal vision, or from multiple images over time that we get from saccadic movement in a single eye. And it works. And there are many applications for this, but the easiest actually to go to town with, to create a product which we're doing right now, is to use it to have over coverage of some area in the visual field that may be blocked for, it seems, whatever reason. We've done quite a bit of testing so far. We're doing more, but we keyed in first on macular degeneration. And if we have macular degeneration blocking or really messing up, as it does, the ability to see in a given limited area of the field of view, you can still get the full field visual information created by the brain from the multiple views that it gets from this lens array and particular software that makes it happen. So we're actually able to correct vision for macular degeneration, which is something that people have thought was impossible.
I think it's just an unbelievable, breakthrough. I couldn't be more excited that you're doing this. So I also want to, ask an additional question, about the technology. How does it, you're thinking about distinguishing it from addressing other various visual obstructions, including cases like glaucoma. What makes the potential game changer in the healthcare landscape if you can do more than just the molecular degeneration?
Yeah, so we've only been able to test a couple of people with glaucoma, so we don't have real critical results yet. I'm not going to make any promises, but so far, we've encountered somebody with a blastoma, a couple of people with glaucoma, and we definitely want to test many people with each of the issues that we encounter, but so far so good. And it seems the general theory holds. I think that if you are born without any visual ability at all, it's not like we can create that. I think the brain has to have experience with images coming in and have that imprinted on your ability. That's my guess. That's a theory. But so far, it seems like we can, and we know that besides just this overcoverage for blocked areas of the visual field, we're also warping the images on a tiny section of the image by tiny section basis. So we can do a digital adaptive optics for people who have, let's say, pitted cornea, corneal dysphasia, various kinds of astigmatism, some other issues that naturally put warps into somebody's visual field. We can do adaptive optics for that. Beyond that, there's tremendous opportunity to do diagnostics with what we have, because what we're doing is sending parallel rays of white light from a display directly to the retina. That means, and a parallel ray means that it's white light, but it's almost like coherent light in the sense that if, let's say, you have a 1 micron wide emitter in a micro OLED display behind our lens, by the time a couple of inches later it gets to the target that it's illuminating, it's still about a micron wide. So we can do what's called structured light imagery. We can illuminate patterns in a repeated form, section by section, throughout the eye. And the same optics work in reverse with our lenses in front of a sensor. So we can triangulate with in-focus accuracy on very accurate light beams. And we can then do really super accurate measurement of everything that we're looking at in 3D and construct a map of the entire eye. And using the infrared range that we get with white light, we can even go pretty deep into non-visible tissue. So going forward, and this is going to take a lot of additional development and approval by the FDA, I'm sure, we're going to have something that is as functional for looking into the brain as optical coherence tomography. And we're going to be able to do that from a pair of glasses that people wear all the time.
That's just unbelievable. This is such a game changer. I couldn't be more excited for your success. So, and speaking of that, in discussing Soledad's work and breakthroughs, can you share a little bit more about the recent achievements, such as winning the Breakthrough Alliance Challenge, which I got to judge and was so happy to be able to pick you, and how these advancements are contributing to the field of healthcare and vision specifically?
We've had the honor to win a few awards recently. Won an award from the AARP at the Consumer Electronics Show. We won the top award from Mass Challenge a couple of weeks back, which is an accelerator that we were in 2022. And it's been a delight. Also, we've had tremendous cooperation from Lighthouse Guild in New York City, which is like winning an award. I mean, it's this tremendous award to work with the physicians and the specialists over there who have contributed quite a bit to what we're doing. And lots of other physicians are now helping us out and allowing us to test patients in their facilities. Just tremendous cooperation from the field. I think a lot of people are excited by it. The biggest award to me, quite frankly, is when I personally run tests with people who suffer from macular degeneration, or in a couple of instances, glaucoma, and they read through our device. I mean, a lot of people come up from looking at the device in tears, saying, you have to bring this out. This is amazing. This is great for my life. So that's really the best award there is.
Great. So my last question. What are you looking forward to the most in 2024? Is there anything new on the radar, or is it getting approval? Like what's big for this year?
We're going to bring out a product. That's what's really new. That's important. So we don't need FDA approval for the minimum viable product. It is a low vision aid device. These things, there's many of these things out in the marketplace. Unfortunately, before us, nothing could actually restore sight. So we think we're going to do something very special in the market, but it's a market that already exists, and it's not FDA regulated, so we can actually bring product to people who need it, I hope by the end of the year.
Wonderful.